Excellent. Folks, I just want to start off by saying, well, Justin and I were quite nervous, as you can imagine, but seeing you all here bright and early, 15 minutes before the session started, means a lot. So just wanted to say thank you so much for being here so early, and hopefully we can do justice for the time you've invested in us, all right? Just on that note, I want to do a quick raise of hands, if that's okay. How many of you experienced the Log4j event that happened a couple of years ago? Awesome, half the room, excellent. How many of you were on the front line, on MIM bridges, having to answer CISOs and CIOs or CTOs, around exposure, blast radius? Any of you on the front line? So 1, 2, 3, you can see a few hands. How awesome was that experience? I'm being sarcastic here, but you get the drill, right? It was chaotic. It was absolutely nuts. Pardon my French here, but it was insane, right? And that's exactly what we want to talk about today, is how can agentic AI help you and your organization be better prepared for situations like the Log4j event? Everyone, I'm Praveen Bhatt. I'm a principal solutions architect coming all the way from down under, or Australia as we like to call it. And with me today, I have...
Hello, everyone. I'm Justin Thomas. I'm a senior cloud support engineer. And I spend my days working and helping customers with cloud operations. So the Log4j event, Praveen just mentioned, I was there at the front line, and I was helping customers, many customers simultaneously. And what I witnessed was chaos. It was organized chaos at scale. And I would be on a call with a customer and helping them trying to find the exposure. And suddenly I would see 5 more customers coming in with the same problem, same questions. So I want to take a look at an example of the same experience. So this is a fictitious company, Manual Everything Corporation. And imagine it's Friday afternoon. The team is ready to wrap up for the week. And suddenly, an alarm is raised. A critical CV gets announced, and now thousands of the instances needs patching. So an emergency bridge call is scheduled. Security director joins the call and asks, all right, everyone, are we exposed or not? Do we have exposure? And what's our blast radius? So first few minutes, nobody answered. It's silence. The platform team hasn't even joined the call, right? And after some time, after we page the platform team, the platform engineer joins, says like, I'm still trying to figure that out. I need to log into the instances, I need to log into the accounts, see how much number of instances are non-compliant right now. And also I need to test this patch that just released before we start deploying to the production. The compliance manager, the IT compliance manager, jumps in, asks, are we doing an emergency patching right now? Or can we do that? Can we wait till our patch maintenance window? So the CTO of the company is listening to all this conversation. It's frustrated because this looks like a scavenger hunt for the right data to make the decision. And acknowledges that we need better automation, we need better intelligence. This conversation is something that I constantly see. First 30 minutes to an hour, we are just waiting. We are waiting for the right people to join the call at the emergency bridge call. And when the right people joins the call, it's the same questions. These questions: which instances are affected? When are we doing the patch? Do we need a downtime, right? So imagine like this single assessment, this conversation is for single CV, and this is going to be for hours. Now imagine doing that for multiple CVs in a month. The team simply cannot scale to do it. And that's why, what if we add an intelligent agents which work alongside with your engineers to help identify and assess these vulnerabilities, check the compliance requirements, and also do the remediation. So your team stays in control, but it is now augmented by these agents to do all the heavy lifting. And that's what we want to show you today, the intelligent agents that we built. And we can move to the demo. The demo setup that we have is pretty similar to an enterprise setup. So we have 3 different environments. Dev, staging, and prod. Each environment has different schedule, patch schedule, and also have different patch compliance requirements. There's existing services already configured. Amazon Inspector, AWS Systems Manager, AWS Config. These are the services which are already detecting your vulnerabilities, already remediating. What's missing is an intelligent orchestrator that leads the way when a critical CV gets released. That's where we add our intelligent patch automation. This is a multi-agent pattern. So there are 4 agents that we create. One is supervisor, and which have control of 3 specialist agents. So these agents are built using Strands. Now, Strands is an open source SDK that makes it easier to build and run agents with few lines of code. And what it brings is a model-driven approach, which means we allow the LLMs to think on its own, to think autonomously, and make decisions to reach the results. And this is deployed in our account, in our demo account, using Amazon Bedrock Agent Core. So Agent Core is an agentic AI platform, which makes it easier to deploy and operate AI agents at scale and safely. Cool, so I will switch to the terminal now, and we can see the patch intelligent automation that we built in action.
Folks, can you see the font okay on the back especially? Yeah, awesome, thank you.
Thank you. Okay, so we call this Patchy. That's the name that we're given for the system, the agentic system that we built. And you can see we have access to these specialist agents. So first thing during what you're actually seeing is a simple chat client that we built to interact with the agent. Naturally, you will build a proper web app in production, which can even integrate with your internal change systems like Jira or ServiceNow. But here, we just want to show it simply how the agent, how we can interact with the agent. So chat client seems pretty simple. Okay, so first thing during a critical event, what I want to know is understand the environment, understand what's running in my account. Right, so even the platform engineer is taking some time to log into the console, log in what my production instances, production environment looks like. So I'll ask the agent just to summarize what's there in my environment. Okay, so I'm going to ask it to also give me the information about that compliance requirements for those production instances. So what we are doing is we are interacting with that supervisor agent that we saw, and it's making that necessary API calls. It's reading the EC2 tags. It's creating the AWS config service. And within seconds, we have the complete picture of your production environment, right? So we get the instance ID. We get a common configuration information about the production. But most importantly, we see the compliance framework for each instance ID. And that's useful information for us to make the decision. So at Manual Everything Corporation, if you see, these information are spread across spreadsheets, Excel sheets, CMDB tools, but here we got it with one prompt. Now, do you remember the first question Security Director asked? It was, are we exposed? What's our exposure? So let's ask the agent to find if there is vulnerabilities in our production environment. So I can just say prod. Cool. So this time, the specialist agent, the vulnerability analyst agent, the supervisor consults that agent, and that's being built to use to query the AWS inspector to get these findings. Now imagine if you're a security engineer, you would do that by logging into the AWS Amazon Inspector, download the findings, check the CVE details, check if there are patch available for that CVEs, then download everything, get a priority list, and we're talking like hours of work, right? Here, within seconds, you will see exactly 37.6 seconds, you will see that we got all those results. So the agent summarizes that there is 50 high severity vulnerabilities that's there in the production environment, and also summarizes which the top critical CVEs based on the CVSS score. So, and which instances are affected by it, and which compliance is at risk if you don't patch these CVE IDs. Now here comes the interesting question, which was asked by the IT compliance manager, is that when is the right time to patch this, right? So there is an SLA requirement of the company. There is a patch manager window. How do we come to a decision when to patch this? So I will ask the agent to come and see and tell us like when is the right time to patch this. Also, if you note this, I just write when should we patch this. I'm not specifying instance ID, I'm not specifying vulnerabilities. It's because like with agent core, we are using agent core memory, which remembers all the conversation history that we have. So it's a context aware agents, and we'll go through that once we see the architecture. But this time, like you see, it's consulting the patch manager agent, that's the specialist agent, and it's checking that what's our patch manager window, what's our SLA, and it gives you a decision. Like it says like patching decision needed 24 days until next window. So your maintenance window is 24 days from today, right? And vulnerability status is, okay, it actually says SLA data unavailable for some reason. Let's actually check again. So the patch manager agent, we'll see the code, and in the Strands, we give this, the patch manager agent an access to a tool which can calculate the SLA requirement. And when we ask this, when should we patch, it actually go and check what's our SLA policies for those specific severities, and then see a delta with the maintenance window, right? Okay, so here it goes. So it says emergency patching required. There's an SLA violation. So there is an SLA deadline because your instances are PCI DSS requirement. So you need to patch within 48 hours. But your maintenance window is 24 days away. So there's like, you are at risk, right? So do the immediate patching within 48 hours. So that's the recommendation, right? So the agents helped us avoid an SLA violation and gave a clear recommendation that you need to patch this now. So up until now, we identify which instances are affected, which vulnerabilities are there, and we came into a decision that we need to do and apply. We need to like do the patching now. So let's ask the agent to do the patching. But I want to like start with dev first. Not we checked everything for the prod right now, but we need to like start with the dev and then staging and then prod. So let's gonna ask, okay, apply emergency patching for the dev instances. So this time also the patch manager agent will come into picture, which is built to do all the systems manager API calls. So when in the patch manager you deploy, you run a run command, and you use the AWS run patch baseline document. Okay, so it's actually asked me to clarify which environment should I patch. Okay, so let's patch the dev environment. Yeah, so it at the back end is is going to generate a run command ID. It's going to target those dev instances, the 5 dev instances, and it will use the AWS patch baseline document for that.
Just if I may add, Justin,
Yeah,
very quickly, I think quite interesting to notice is the smartness of the large language model to be able to understand the fact that you've been discussing about production the whole time, and all of a sudden you're saying you want to switch to the dev environment, actually trying to get a confirmation, which in a lot of instances doesn't really happen. And again, it's something that you'll notice the more memory, the more context that the large language model has, the more aware it is about your organization, your processes, the better it becomes with such things.
Yeah, thank you. So we can see like a command ID is generated, the status right now is pending. So 5 dev instances are targeted. So we do have some next steps that provides by the agent that we can check the status, or also we can type proceed to continue the staging environment. So basically agents understand that this is a phased rollout. So we started the dev. I didn't specify that it's going to be like staging a prod. So it understands that if I type proceed, it will start patching the staging environment next. Or we can wait and check and verify if everything's fine, and then we can do that. So we avoided an SLA violation, did the emergency patching, right? But what about the times that we were not able to catch that SLA miss? And that's what the CTO of Manual Everything Corporation is thinking right now. How many times we were non-compliant just because the team were busy doing the scavenger hunt for the data? And this is something even the auditor is going to ask, what was your compliance history, right? So Manual Everything Corporation does not have a tool to get this. So let's ask the agent to get how many times did we miss the SLA. So this time is the last specialist agent, the compliance analyst agent, is consulted by the supervisor agent, and what it does is it fetches the reports from S3 bucket and then do the math. It checks when was the vulnerability released, when we did the patching, and also check the SLA policies. Yeah, so it actually checks the SLA policy and see like how many times we did the patching, which should be like done within the SLA timeline. So it says there are total 6 breaches in the last 30 days, and also gives the breach details, like these were the CVE IDs that were like breached, and these were the team that were affected by it. Okay, so yeah, so next we want to like explore the architecture. We want to explore how we build this code and how we come into like the decision principle that we took when we were building this. And for this, I will hand over to Praveed.
Awesome. Thanks, Justin. Couple of things that we'll kind of highlight as we get into the code is the patch manager or the patch manager agent itself has the ability to verify or do health checks as part of its patching process as well. So the reason why we can do it just in the interest of time, but under the hood, it's basically checking your application, your infrastructure. And we'll go into detail of how it actually does it. And once it completes its patching, it's uploading all that information into an S3 bucket, as Justin kind of pointed out. All right, now that we've seen the solution in action, let's have a look at the underlying architecture and code that drives the solution. As you've already noticed, we've got multiple agents in the mix. This is based on a pattern called as the supervisor pattern, wherein you've got a supervisor agent that manages the end-to-end orchestration of the whole workflow, while it consults or coordinates with specialized agents, each of which have a specialized role, set of instructions, a set of tools that it can use to be able to complete a given task. Now, you might all know this, agents by themselves don't have the ability to understand the user intent, cannot reason. And for that intent, we have Claude Sonnet 4.5 as a large language model running on Amazon Bedrock that gives it the brain power. Now, even with all the brain power, the agents need to be able to interact with AWS services. For that, we have specialized tools that are exposed to these specialized agents. Justin's mentioned this, but very quickly, in terms of the AWS services we have in the mix are Amazon Inspector for vulnerability findings, AWS Config to give the agents an understanding of the resource dependencies, so when it actually makes a patching decision, it understands the business criticality that might have an impact on the whole patching operation. Right? If it's a let's say a web app, a front-end facing application that has extremely high business impact, you don't want to do it, or you don't probably want to patch it. Right? So all that decision is factored in by the patch manager agent. This, in your case, could be something like a CMD, like CMDB, like a ServiceNow or a Jira that you're using. But anything that is able to give the resource dependency view, the large language model will absorb that information and make it available for the decision-making process. Systems manager to understand the patch compliance state, to apply the patches. And then you've got S3 to store and retrieve the compliance reports. And finally, EC2 to apply the patches themselves. We're using Strands SDK. Justin's mentioned this. But the one thing I want to highlight why Strands is for one key reason. Strands makes it very easy for users to be able to build agents that can interact in a continuous manner with the large language model and the tools in what's referred to as an agentic loop. What that means is, think of a scenario where a user puts in a request. Right? Patch my instances in dev environment. The agents don't understand it, so they've got to understand the intent. This request gets routed to the large language model. The model says, all right, I understand the intent, but I need access to tools that can interact with AWS services. So the request gets routed to the tools go talk to the relevant services, come back with a response. That response is fed back to the large language model. It reasons that and goes on and on and on until the user's original request is completed. Now, all of this happens within what's called as an agentic loop. You don't need to code it. It's just made available to you, and I'll show you when we get to the code itself. And very quickly, in terms of scale and security, it was super easy for us to just deploy it onto Agent Core. Agent Core comes with 7 primitives, if I'm not wrong, 6 to 7, but we're only using 3 of those. Runtime to actually host and run our agents, memory for making the agents context aware, and finally, observability to be able to understand the state of our agents by using tracing, metrics, logs, all of which are very, very useful when you're trying to debug a situation, when you're trying to iterate or evaluate your prompts, you're making changes to your large language model parameters, et cetera. All of that observability makes it super easy for you to get that information. And that's it. Now, when Justin and I came up with this idea, this is like 4 months ago, we didn't start with this whole idea, in like this sort of architecture at all. We thought we'll start off with something super basic, super simple, understand the capabilities of large language model, understand what enterprise users would prefer in this capability. So we thought we'll start off pretty small. And then we continue to iterate, get feedback from customers, and then iterate it again, and then again, and again, and again. So we thought in the next 30-odd minutes that we have left, we'll kind of take you all on that accelerated experience of how we started off with something very basic, and then how we iterated, and how we got to the stage where Apache is today. So hopefully you can leverage the tips and practices that we followed, the architecture patterns, to get you and your teams to a stage where you're more comfortable to be able to handle the Log4j event. Sounds okay? Cool. I'm going to swap quickly to my demo screen. All right. Excellent. Okay. So what we started off with first was a super simple EC2 agent that could just list all your EC2 instances, get the compliance state. All right, so let's just start off with that. Okay. If it's okay, I'm just going to get rid of this screen. Make this a little bit on the left. Yeah, perfect. Can you see okay? All right. So I'm going to start off with some importing of some main class. So the agent class is the main class because it's the core interface into your large language model for your conversation management and all of that. So this is the most important class that you need. And then for your agent to be able to, wow, I'm a terrible typist. For your agents to be able to interact with your AWS services, you need a tool. And Strands has this built-in tool called as Use AWS that's available with the Strands library. And then I'm going to just quickly define the agent. Start off with a name. Yes, agents have their own identity now. And then give it a system prompt. System prompt is where you specify the role, the persona, the traits, the instructions that you want your agent to have. In our case, I'm going to keep it very simple. You're an EC2 assistant. That's it. And finally, don't forget the tools. You're going to say use AWS, which is a tool that allows the agent to interact with AWS services. That's it. 6 to 7 lines of code within Strands that allows your agent to be able to interact with the EC2 services in your account, get the list of EC2 instances, and then interact with Systems Manager to get the compliance state. That's it. So I'm going to quickly start off. I'm going to say list all my EC2 instances in prod and their compliance state in US East 1. That's it. I'm going to run this. All right, Python. So hopefully I didn't make a typo. Yeah, so what you're seeing at the very top is I'll help you list all your EC2 instances. That's the large language model actually understanding the user intent, and it's figured out that it needs to do a few things, which is get the EC2 instances, then get the compliance state. And then you see the tool invocation, the response that comes back, the intent is being reasoned by the large language model, and goes on, right? So you'll see multiple tool invocations happening, and then it comes up with the final response, which is like, here are all your production instances, are they non-compliant, compliant, and a bunch of other information that I probably didn't need. But anyways, this is just a basic agent, right? What I do want to highlight is the agentic loop again. The large language invoked the tool, got the response, and as you can see here, I don't know if the highlight is working, but the invalid parameter value exception. And we've reached a stage where large language models can autocorrect themselves, figure out that the syntax that it followed was wrong, goes back to its knowledge base, figures out what's the right syntax, and submits that again. And it probably tries AWS config. There you go. Because we said compliance state, it goes to config for some reason to get the compliance information, and then figures out config doesn't have it, and then autocorrects itself and tries to get that information from Systems Manager, which is here somewhere. Yeah, I'll use the Systems Manager compliance API to get it. So that was it. So we realized like we can do a lot, but the performance was not optimum. The fact that we had to go 5 tool invocations sometimes 7, it wasn't ideal. So we thought, how about we make the agent more richer, more powerful, give it more tools, and tweak our system prompt. So at this point in time, we went with something like this, which had, just going to remove this, the same agent, but with slightly more enriched prompt and better tools that it has access to. And I'll explain to you a bit more of what's happening under the hood. So you've got Bedrock model defined. When we didn't define one with Strands, by default, it uses Cloud Sonnet 4 today in US East 1, and also sets up all the parameters like temperature, top P, which controls creativity, and a few other things like max tokens as well. It has default parameters which might not be suitable for our use case. So we had to control that as well. And in our case, we just tried, like, can we use Nova, which gives us better cost of performance to see how it works. So this was a second iteration. Literally, this was it. And then control the temperature element to control the creativity of the large language model to make it as deterministic as possible. Now, for all the Python aficionados, you can see the tools here. I've got 2 tools, one to get the EC2 instances, and the other to get the patch compliance state. It's just a Python function leveraging Boto 3. That's all it is. The only difference is the fact that we use a tool decorator, which exposes a Python function to be used as a tool by the large language model. And the way it does it is by the doc strings. The doc strings, as long as you're clear and structured in terms of what the tool does, it knows when and how to use it. So in this case, you just say get EC2 instances, optionally filtered by environment, so on. That's all it is. And same thing with the get patch compliance. We're doing the same thing here as well. Right? So that's the tool bit. Now, coming to the prompt, previously we saw just the you're an EC2 instance. Wanted to change that because you could see all that additional information coming through which we didn't need. So you could control that using what's like a behavior, which are basically set of instructions that I'm giving to the agent to ensure that it follows a few things that I wanted to, which is like, give me the exec summary sort of to begin with, and then the details, markdown tables for multiple instances, use the default region if it's not mentioned. But here comes the interesting bit. I'm building an EC2 assistant. I don't want anything else. So you can control the scope and the role that it needs to perform using a prompt. Right? In this case, I've just said, if user asks anything about non-EC2 related queries, just respond with saying, I don't handle it. Simple as that. And then being explicit with your tools. Again, you don't need to. It's a personal preference because the doc strings itself help the large language model understand when it should use the tool. But I'm just pedantic. I prefer to be very explicit, make sure the agent understands what it needs to do. And then the output format. We're using a chatbot on a terminal, so had to follow a certain set of instructions from an output point of view. And then the tools. As you can see, we're not using use AWS anymore. We just have two tools. I've got a very basic while loop just to start thinking about a chatbot experience, and that's all it is. All right. So let's invoke this one. I'm going to say clear, yeah. Python EC2, but with tools. Comes with a request, so I am going to copy paste my previous prompt itself, so you can see exactly the behavior, but this time with a more smarter agent. So you'll see the streaming information of what's coming through, and this is one of the reasons why we built a chatbot on a terminal, just to show you the streaming behavior. We probably could have done this with a web app, but it was just a bit more easier with a chatbot. So you can see it figures out the intent, and then it makes only 2 tool calls. That's it. If you remember, actually, before I go, just observe this behavior as well. This is quite important. The fact that it just sort of types one line at a time, and I'll just explain what's happening under the hood and our experience, why this is not ideal. It just did 2 tool calls. If you remember, the previous agent did 5, sometimes does 7, sometimes 2. It's unpredictable. With tools, you start getting more predictable, deterministic behaviors. Now, to the point again of that single line being printed, that's because the tool that we had for patch compliance state only allowed for 1 instance at a time. So the large language model is basically making 5 instances, 5 API calls to systems manager to get that information. Not ideal. Batching is the way to go, but we realized that the hard way. Not the hard way, it's just, I think we were being lazy. I'll show you one last thing around the scope. List all my Lambda instances. Now, if you remember, this is just an EC2 agent. Shouldn't give me any information. So from a security point of view, I can build in guardrails. It's just one way to do it. There are other ways as well, probably some things that are more harder, but this is one way to actually achieve it, especially when it comes to injecting for the lack of a better term, I'll say crap into your prompt as well. So this is one way to actually achieve it, is having controls in place within your prompt itself, within your system prompt, sorry. So it just says, I only handle EC2 related queries, ignore the duplication, but it's just saying, I only handle EC2 related queries. And the same would apply if you keep trying. So that's it. So we reached a stage where we realized, okay, we're able to do a lot more than with use AWS, so we started building more tools. But the agents started getting heavier and heavier. So we got to a stage where it started becoming monolith versus microservice sort of debate again. Should we go with a single agent, or should we start splitting into multiple agents? And the reason why it was becoming more obvious for us to go down the latter path was because of the hallucination, the confusion. So simple sort of philosophy we started following was, if an agent is not doing one specialized task, then it should be broken up. Right? So again, it's a philosophical debate. Again, monolith versus microservices, not gonna get into it. I'm pretty sure we're gonna spend all day, maybe all week on it, but we're not gonna get anywhere. But the reality was for us, we started getting better results by breaking it down. And evolving it and adding more tools, we got to a stage where Apache is today. And I'll just walk you through the Apache code base now. All right, I'm just gonna close these things. I'll close this as well. So just very quickly in terms of the project structure, all of the agent-related code is within the agent folder itself. We have a helper function within the helper folders, and I'll walk you through that as well. But just very quickly, the Bedrock agent core YAML file that you're seeing in the Docker file, these are pertaining to the agent code deployment. So they are the configuration file in the Docker file that's used by the runtime to be able to deploy agents. Everything else, which is the 4 agents, that we've got the patch manager, supervisor, vulnerability agent, and compliance analyst. Right, super simple. In the helper functions, very simple ones. We just have memory, globals, and a few other things. But the key thing I want to highlight is the tools file. So you can either have the tools embedded within your agents, but the fact that I come from a software engineering background, it was easier for me to just externalize and have it all in a separate file. Just made it easy for maintainability and readability and a few other things, and you can always import it, right? As simple as that. So I've already walked you through a few tools. I'm not going to bore you with that again. I just want to show you one tool and just what does good look like from our perspective, I guess. So we've got to get vulnerability findings here. I'm going to just remove this so you can see the whole screen. Again, tool decorator, but there's probably 2, 3 key things that I want to highlight here. Is one, the doc strings. Again, if you have been writing Python code, you're familiar with this. But being as clear and structured as possible makes it that much better for large language models to be able to understand when and how to use a tool. It's garbage in, garbage out. It's as simple as that. So in our case, we define what the purpose is, the arguments, the CVID, severity, environment, limit, for example, being very clear in terms of the default values, giving examples where possible, and what it returns once the tool is invoked. Try and return dictionary objects where possible. The more context that the large language model has, compared to, say, just a string output, the better it will be in terms of providing you with more richer information as an output. Okay? Now, one thing I do want to highlight, this is probably my second thing or third thing I can't remember, is the fact that you have optional and required or mandatory arguments. You can basically control the behavior of agents using this one thing. To give you an example, let's just say in get vulnerability findings, if my severity was mandatory or required, when the large language model is invoked, so let's say Justin in his prompt says, give me all the vulnerabilities, and that's it. He just says, give me all vulnerabilities. He's not mentioned the severity at all. At that point in time, if this was required or mandatory, the large language model, rather than assuming that, hey, the user is asking me for all of it, so he probably assumes, they assume that it is critical, because critical is high, so I'll just go with the critical findings. There's an assumption being baked into the large language model. However, if you enforce it, then the large language model will question or check with the user again to say, do you mean critical, high, medium, low? So you can control the behavior using just the arguments itself. Other than that, it's not rocket science, right? It's a simple Python function. We're using both of 3 clients to be able to get that information for vulnerability findings. That's it. All right, moving on to supervisor. I'm just going to have a quick look at the time. Okay, we're good on time. So this is the supervisor agent that we have, basically the one that controls the entire orchestration for the workflow. Now, for the supervisor to be able to interact with the agents, we're using a pattern called as agents as tool. If I scroll all the way down, you'll start seeing what I mean. Actually, I'll just mention one thing very quickly. So here it is. So you'll see these 3 lines. We're importing the 3 key agents from the different files that they belong to, and we're making them available as tools by using the tool decorator. So I'm going to scroll down very quickly. Here it is. So this is just the consult vulnerability analyst, which is the agent itself, the specialized agent. We just pass the the natural language request in as a string, allowing the vulnerability analyst to be able to understand the intent of the user. So all the supervisor agent is doing is understanding the intent, passing that request on to the specialized agent based on their capabilities, and I'll walk you through that as well. And then let the specialized agents do the rest. That's it. So in this case, we've just got the 3 tools. We're also using the use AWS tool if in case a request is outside the scope of any of these 3 agents. So I'll walk you through very quickly the system prompt itself here. You're defining what the role is, so which is a patch automation coordinator, routing request to the specialized agents. And I have some response guidelines in terms of what are the things it needs to follow, like verbosity in terms of the output, being very direct, what we actually need, what format do we need it in, instead of pagination truncating the data if it's more than 10, as you might have seen, it said 50 severities available, but only showing 10, for example, and those kind of things. And then the routing priority. How do I want the request to be routed? Which is understanding the user's primary intent. If it can't find that information, go to the context from the memory itself. And if it can't find that as well, then route to use AWS. And that's it. I just provide the details around when to use the specialized agents, which is analyze security vulnerabilities, CVEs, et cetera, et cetera. So you can use semantic routing, keyword routing, or capability-based routing as well. So this is just one way we could do it. And that's it. We mentioned the tools again. Now, if you recall in the second agent from memory, when the tool started printing out one line at a time, this is what I was trying to get to. With tools that you've defined, you can control batching. Right? So if you've got an API call that has to be made 10 times, 20 times, then you can control it. But something like use AWS, which is a built-in tool, you can't control it. So you're using the prompt itself to be able to control the large language model's behavior of how it should use or leverage that tool. So in this case, batching related queries, using filters to reduce data transfer, this all helps in reducing the token consumption. Yes, we have to pay for tokens, and we realized that again as the cost started going up. And that's it. It was just the output format, like emojis, et cetera, to make it look appealing. But that was it. That's the supervisor agent, just to give you an overview. I'll show you Patch Manager very quickly because that's the most complex one, and every other specialized agent follows the same sort of format. As you can see, we've got a whole heap of helper tools available. It's just because we wanted very specific capabilities to come out of it. We wanted it to be deterministic. We wanted it to be consistent. So, just walking you through it, we defined the scope very clearly because what we observed was when the scope wasn't defined, and you might have observed this as well, the supervisor agent, when a request comes through, routes it to multiple agents. If a specialized agent is not able to perform the said task, and it's because it's not in scope, it comes back with an out-of-scope response. And the supervisor agent now needs to correct itself and figure out which other specialized agent that it needs to route the request to. So this is extremely important and something you might want to keep in mind. Now, as you might all appreciate, patching as a process is extremely rigorous. It is very controlled. You don't want it to just be done in a hilly-billy way. You want to control that whole form. So when we started off, Patch Manager was doing things in parallel when it shouldn't, like it was trying to do dev and staging at the same time, trying to be more efficient. But we realized that that's not the way it should be. So we had to bake in this concept of workflow within the prompt to control its behavior. So the way we kind of started off was like, get the CV severity first. So either the user provides that in the prompt itself, saying, hey, give me the critical severity in the dev environment. And if that's not available, if it's available in the memory, extract it from there as well. So it has different ways that it can actually absorb that information and use that for its calculation, and we'll get to that in a minute. Then get the patch compliance. So we have multiple applications running within these instances, each assigned a compliance framework that has an SLA associated with it. So get the patch compliance state based on the environment and the severity that's been provided. Now, the next step is to get the maintenance window for the said environment, which is when is the next execution from a patching perspective going to happen. Now comes the smart decision-making ability of the Patch Manager agent here. Now that it has the severity information, understands the SLA of your application, it needs to make a decision on if it has to patch it in an emergency form, which is straight away, or can it wait for the next maintenance window. That all happens with just a few lines of code rather than a pretty large if-else statement that we would have probably written too complex for anybody to understand. And that's it. And then just display that information, which is, hey, window is within or beyond the SLA deadline. So we need to either patch it now or leave it for later. That was it. So that whole workflow was baked into the prompt. Could we have optimized it? Absolutely, but we reached this stage based on a lot of tests. Last week, we had a release. As we're getting closer to reInvent, we're actually in reInvent already, but there's a lot of new announcements. So one new announcement was Strands SOP, or Standard Operating Procedure, wherein a lot of the workflow sort of implementations can actually be externalized, which makes the prompt a lot more smaller, which means less token consumption, more faster large language, more faster agent responses. All right, then comes the instance ranking. So it's done the calculation on emergency versus not emergency. It also has the ability to rank your instances based on business impact and blast radius. And then actually go through a phased execution. This would have taken a long time, hence we couldn't show it in the demo, and as I mentioned that previously. But under the hood, it has awareness that it needs to go in a phased manner, even if it's an emergency patching situation. And it does that, keeping in mind that health verification is extremely important, which is mandatory after each environment. We've all observed this when you patch, applications are, experience something and they just go down, you're impacting your uptime, et cetera. So we kind of built a very simple health verification system. You could build a more complex one, obviously, but the logic is the same. We got 2 layers of checks. One is a simple ping check with SSM, which is for the infrastructure layer. The second one is for CloudWatch alarms. Now, in your case, you could integrate your agents as a webhook with Splunk, New Relic, Datadog, whatever you use, to see if any alarms have been triggered as part of the patch. And if it does happen, it can roll back. How useful would that experience be wherein you can just roll back a patch that you apply because it's broken a system? And it's also smart enough to figure out that it only rolls back that environment. So you can compare a delta between a previous or a lower environment that you've patched and was successful compared to this environment as well. And finally, all this information needs to go somewhere for compliance reporting so our CTO is happy, and that happens with a specific tool and all that information. And that's it. We had rollback policy, output format, but this is pretty straightforward. Couple of things I want you all to take away from a prompt perspective. I'm sure you've all experienced this. As much as I want to say prompt engineering is an art, it feels like there's a lot of science behind it now. A few key tips that have helped us is keep them as structured and clear as possible. Keep them concise. The more verbose they are, every time the agent actually is working with your specialist agents, they are taking a lot of this with it, makes it really hard, becomes more expensive. And keep in mind that you don't have conflicting instructions at the top and the bottom. Right? It's happened a few times where you've said something at the top and the bottom is completely different. Agents confuse quite easily in that regards. Exemplify. Show them an example of what good looks like so that they use that as a pattern moving forward. Yeah, that's pretty much what we had in terms of the code itself. What I'm going to do very quickly is, oh, I think I had, yes. Can I just change that to PPT? I think we've all seen, like Justin's already shown the demo. I've gone through the code base with you. And look, if you have time, we're more than happy to take questions, either offline, depending on how easy is Romy going to be on us. But we're happy to take questions or just go out of the room and answer any questions. But we've just seen how agentic AI can help you, manual everything corporation, be better prepared, right? It's technically and operationally viable. It's not if, it's just a matter of when. Not saying it'll just magically solve it tomorrow, but I think we're very, very close to a stage where answering questions for the security director of what's a risk, a blast radius, that was just done in seconds, right? You no longer are dependent on application owners and application teams to give you that information. You can get that within a matter of seconds. Platform engineers now have the confidence and the comfort knowing that if they apply a patch, they can roll that back. This is especially useful in a centralized environment where you have application teams, platform engineering teams, cloud teams, et cetera. Super useful. Compliance managers are feeling a bit more at ease, knowing that they don't need to rush through a critical vulnerability just because it's critical. If it fits within the maintenance window, they can make that decision sooner. And the CTO is super happy that they're not going to be in the press because they're more compliant. They understand the health of their business from a patching perspective, and they can continue to help the teams evolve and get better. So if there's 3 key things that we want you to take away, are these 3 things here. Tools versus prompts. I think we get to a stage where, again, it's getting a bit more philosophical, but what we've experienced is tools is more deterministic, more consistent. Prompts is more creative. It lets the large language model think on its own. It works sometimes, it doesn't work sometimes. So keep that in mind when you're trying to build when you're trying to get to a certain outcome, think about it when you think about tools versus prompts. Augment over replace. I think a lot of people think like AI is just going to, and this is a controversial statement, I think AI is going to take over the world. I think it will eventually. We're not at a stage there yet. Whatever we've shown you today is showing augmenting capabilities of an AI to make your teams, make your systems more smarter, more powerful. So they're meant to augment over replace your existing systems. Agents will give you the scale, the agility, but they need humans to provide the governance and oversight, without which it's going to be a really bad situation for all of us. And finally, build small, test and iterate. We didn't get there on day one. We've taken a few months to get here. Again, we've got our day jobs, but I'm sure if we had put our mind in, just like you would, you can accelerate through the whole experience. But start small, test and iterate. Use your observability tooling to get to a stage where you understand what it can do, what the responses look like, before you tweak it, right? Take your time. And one key thing, if I could highlight here, is even if you're not a software engineer, please follow all the software engineering practice in terms of version control. Look at tools that help you with model evaluation, prompt evaluation as you tweak your prompts and models. The parameters, they're super useful. We are planning to publish the code soon, but whatever we've built has been based on patterns and samples that are easily available. So these are the QR codes for Bedrock Agent Core Code samples and Strands Agent. Hopefully we'll have our code published soon. But in the meantime, you can try and take the lessons you've learned today, hopefully, in terms of the patterns, the architecture principles, and apply them with these samples. And everyone's here for swag, I'm pretty sure. If you're not, you can come for the demos. We'll be there as well. But please do visit the CloudOps kiosk at the AWS Village. But yeah, just on Justin and my behalf, thank you so, so much. We do have 5 minutes, so we're happy to come around and take questions, if that's okay with Diggy. But yeah, thank you so much. Really appreciate it.
Thank you.